In this question, we are given the function f of x equals x cubed plus x minus 1 defined in the interval -1 to 1. This is a closed interval. And we have to verify that if this function f of x satisfies the mean value theorem. So here I have outlined this mean value theorem, and it says that if f of x is continuous on the closed interval a comma b, and f of x is differentiable on the open interval a comma b, then f prime of c equals f of b minus f of a over b minus a. So let's check the conditions for mean value theorem. These are the two conditions that we have to check. That is, f of x has to be continuous on the closed interval -1 comma 1, and it should be differentiable on the open interval -1 comma 1. Clearly this function is continuous because this is a polynomial function. It's a polynomial function in x, and so all polynomial functions are continuous in their domain. So going by that justification, we say that this function is continuous in the interval -1 comma 1, as well as polynomial functions are also differentiable in their domains. So again, going by the same justification, we say that this function f of x is also differentiable. This is also differentiable in the interval -1 comma 1. And this means we have verified that this function f of x satisfies the mean value theorem. Okay, since we have determined this function f of x satisfies the mean value theorem, we can utilize the conclusion of the mean value theorem, that is f prime of c equals f of b minus f of a over b minus a, to determine the value of c. So let's do that. For that, I'm going to first to find the derivative of the function f of x. Since we need f prime of c, we first have to find the derivative of f of x, which is f prime of x, and this equals, I find the derivative of each terms on the right side. The derivative of x cube is 3x squared when we use the power rule, and the derivative of x is 1, and the derivative of -1, which is a constant, is 0. So it's basically 3x squared plus 1 is the derivative of the function f of x. Now since we want f prime of c, we replace x by c into this derivative function. So therefore this gives f prime of c, and this equals 3c squared plus 1. So in the conclusion of the mean value theorem, we have determined f prime of c, and that means we can use this equation, that is f prime of c, this equals f of b minus f of a over b minus a. Let's identify the a and b so that we determine f of b and f of a. In the interval, the first value is a, and the second value or the last value is b. So we know that a equals -1, and b equals +1. And let me also copy the f of x, and this equals x cubed plus x minus 1. So let's use this equation. This becomes f prime of c, and this equals, let's substitute a as -1 and b as +1. So therefore this becomes f of b, which is f of 1, minus f of a, which is f of -1, and this over b minus a, that is 1 minus a is -1, so it becomes 1 minus of -1. And we have to determine this f of 1 and f of -1. We can replace x by 1 to find f of 1. So I put x as 1 into f of x to determine f of 1. So therefore this becomes 1 cube plus 1 minus 1. 1 minus 1 is 0, and 1 cube is 1. So f of 1 is 1. Let's also determine f of -1 by replacing x by -1 into f of x. So when we do that, we get -1 cube plus -1 and minus 1. -1 quantity cube is -1. We then have -1. We also have one more -1. So this is negative 1, negative 1, negative 1 is negative 3. So we have determined f of negative 1 equals negative 3. We will utilize these two things and substitute into the equation. So therefore we have f prime of c. I'm sorry, we can also replace the f prime of c, which we have already determined here. That is 3c squared plus 1. So let me put this as 3c squared plus 1, and this equals f of 1 is positive 1 minus f of negative 1 is negative 3 divided by this is 1 plus 1, which equals 2. So let's simplify this. This gives 3c squared plus 1, and this equals this is 1 plus 3, which is 4 by 2, and this gives 2. So we have the equation 3c squared plus 1 equals 2, and when we subtract 1 on both sides, we get 3c squared equals 1. So we solve for c squared first by dividing both sides by 3. So we get c squared equals 1 by 3. We then take a square root to determine the value of c. So when we do that, we get c equals plus or minus the square root of 1/3, or else we can write this as plus or minus the square root of 1 is 1, uh, so we can write this as 1 over square root of 3. So we get two values of c, that is c equals 1 over root 3. I'm going to put this in decimal form. This is approximately equal to 0.577 when rounded to three decimal places, and we get one more value of c, that is c equals negative 1 over root 3, and converted to decimals we get this equals approximately negative 0.577. However, we have to verify that if these two values lies in this interval. So the interval is negative 1, 1. We see that 0.577 lies in this interval. Also this value, that is approximately negative 0.577, and this also lies in the interval negative 1 comma 1. So we can be definitely sure that these two values satisfies the mean value theorem. That is, this value of c lies in the interval satisfying the mean value theorem. So we finally see that c is approximately 0.577, or c is approximately negative 0.577. So these are the two values of c which satisfies the mean value theorem for the given function which lies in the interval negative 1 comma 1.